Hi guys, Dr. Tracy here, computer science. I wanted to talk a bit about the subject for the week, which is pointers and structures. If you looked at the announcement that was sent out this week, then you will see that pointers and structures is where what we're doing. We're finally done with the review and the teach back, and now we can go to the kind of structured class that I think you were waiting for. So there is pointers, which is the page that has all the information that you're going to need to use for this chapter. So we're going to look at that page in a second. There's also a discussion that you will do as part of this week, and there's projects that will be assigned and submitted at the end of the class as part of your Project 2 lab notebook. So let's look at what's going on this page. If you take a look at the pointers page, please do. I've put on there a PowerPoint, which I'm going to briefly go over right now and probably hit up again tomorrow during our Zoom meeting. But I've also given you some additional resources on pointers from C Programming, Learn CPP, Tutorials Point, and Code Project. And also because the text talks about the stack and the heap, I've given you a couple of examples there. Tomorrow when we meet on the Zoom meeting, I'm going to go through the worked example so you can have a good idea of what's going on. But as far as the assignments that are due on this page, you have a discussion in a lab notebook programming projects. These lab notebook programming projects are literally the programming projects at the end of the chapter. They are divided by numbers and they are the very end. So when you get to the end of the chapter, you can see this section and you're going to do 6 of them. 6 of them is a lot of work, but they aren't due until December. And I'm going to be adding lab notebook programming projects every week. So in December, what you will submit to me is a lab notebook that has links to all of your online projects that are working and then you've checked them. So the thing you really want to work on this week before you get started in lab notebook programming projects is the discussion section. And there's lots of questions on this discussion. This discussion is about pointers. How do you use them, declare, initialize them? What does it mean to have dynamic memory allocation, the heap and the stack, common programming situations that could involve the use of pointers, dangling pointers, memory leaks, character pointers, function pointers, the array pointer duality law. That's fun. And then also it talks about structures, not necessarily related to pointers, but that might be also something to answer. Okay, so let's talk about this pointer stuff that is so awesome. When we have a variable, it contains a value, but a pointer is the location of that value within memory. Every box, every slot, every piece of memory is denoted by an address. And inside of that address is the value of the variable that we've chosen to save so that we can access later or modify. But the address at that location is actually what the pointer is. And we can set pointers from one location to another to detect what the value of that variable is. The reason why we use pointers is because if we need to use a value, but we don't want to duplicate that value by using it locally within a function or using it elsewhere within the program, we can instead use a pointer, which inevitably will cut down the memory use in the program by stopping from having to use double memory space just because we are using some values that exist globally and putting them local. Pointers refer to values that are allocated on demand, and they are necessary for implementing what's called polymorphism. Polymorphism is a concept that describes that things can have multiple uses. So let's, as an example, Harry needs a banking program. Harry wants a program to manage bank deposits and withdrawals. So if we have a deposit amount and withdrawal amount, they're from the same bag, but they're going to change based on the pointer. So by using a pointer, we can switch to different accounts without modifying the code for doing this. You can see this example where Harry starts with a variable for his account balance. And then as we create the object that's going to make use of the account, we create a pointer which will point to the same variable. So this is a visual depiction of what pointers look like. So Harry's account is put in a location in RAM, a little slot, if you will, that keeps the ons and offs that store his value. And that is, in this case, 20300. There's usually a numeric address that's assigned to every block of RAM. And this is just shown as 8 bytes of RAM and what it would look like and what its value is. So then when we do something with Harry's account and we're going to do a different program to run a withdrawal instead of running just having his account have a balance, if you're going to run a function, when you create that function, it might have a separate value, and so a separate use of the Harry's account balance. So instead of having to copy that balance into a function just so we can run the total, we make a pointer to it and saying that's the number I'm talking about, and I don't want to make duplication. So instead of just pointing to the account, we point to the number. That way when the balance changes or updates or is modified or whatever, it will affect a different program. When we use those addresses, the way that it works is we use them just as we would normal variables, except that we use them saying that now there are two pieces pointing to Harry's account balance that are pointing to the exact same thing. And when one is updated, the other is also. And when we use a pointer to find out what the balance is, all we have to do is to look at the pointer and we dereference that operator by saying, I don't want the pointer address, I want the actual value. And so this way we have the copy of a variable posted in two different places. And that's what's demonstrated by this example. So when Harry makes a deposit into a joint account, we can use an account pointer to show what the balance is, and then we can read from that function to be able to adjust that balance, and it will update the existing account. The way we put values, as shown in this example of pointer syntax, is if we have an expression, it has a value that's the address. The value stored in that address is dereferenced using an asterisk. The address of any variable is using the ampersand. And if we use the ampersand in a statement like P equals ampersand N, what we're actually saving is not the value of P, but rather the address of N in P. Asterisk P is going to get the value stored at the changed address, and something like M equals asterisk P means that we're going to store the value into the address that's given. And so this walks through the example of M is equal to 10, N is equal to 20, and their addresses, which one is available for which. I hope this helps on a basic understanding of programming. I have a little bit more to talk about, but we will end with that for now. And take a look in the text at some bad syntax examples and uninitialized pointer values, because you can get into trouble when you're working with pointers and don't necessarily have an ability to use them. So there's a lot of this examples in this as errors in this PowerPoint that I've given you. So we'll add some other videos in a bit.